You know, I think one of the problems is computer science in an education space. And I should also preface this by saying I worked for the university for about 5 years as well. So I have, in IT, so I have an interesting perspective both having been at the School of Engineering and then working on the other side of it. You know, computer science has been typically this very hardcore science / mathematical based study at a lot of the big major universities. And so you do wind up with this huge gap. I think, how do you address that? I mean, it's hard. I think we need to, you know, I don't know that it's something that any one company or individual can do, but I mean, I think long term, education has to take a hard look at the reality of, you know, not everyone is going to be a scientist or a Nobel laureate, and that we need to maybe look at what is higher education. You know, a lot of times higher education is kind of designed around this pursuit of, well, you're going to get your bachelor's, and then you're going to get your master's, and then you're going to get a PhD, and you're going to do research, and that's higher education, you know, at a major university. And that's great. I mean, we need that. But also we need, to your point, we need a little bit more education on people. You know, I have no desire to ever be a PhD. I'm not that smart, you know, but I do want or wish I had been able to learn things like better about design patterns and that sort of stuff in college.
Yeah, I would agree with that. I think design patterns are actually the key for education in the universities. I mean, I went to MIT and there what they taught was Lisp was actually what I learned, right? So, oh yeah, never used a car or a CUDA in my entire life, right? Okay, that wasn't the point. The point was they wanted to teach me about design patterns of recursion. Right? Then when I wanted to get that seeped into my brain, at the time that was modern, right? Whatever, right?
Sussman-Navelson, right?
Yeah, exactly. Right? And that was the point. It wasn't the language, it wasn't the syntax, it was the thought patterns, it was the design patterns. And so when you come out, you say, I can learn whatever language you want. I can do recursion in COBOL, right? It doesn't matter, that's not the point. And so I think the more we can get our universities to infuse design patterns and thought patterns of software engineering, the better off we'll be.
Well, I think in previous questions, you've all kind of skirted around it. And it's like, it's fundamentals and it's history of computer science. To be quite honest, you know, my background was AI. And knowing what a Blackboard system was helps build those concurrent, highly parallel, you know, systems that we need to do to handle the massive kinds of technologies. Now, no, you're not going to go build your own Blackboard system anymore, right? But it's kind of this notion of history, of how they build things, and the fundamentals of, you know, you don't have to program in C anymore, but knowing what a pointer is and how to use it and what you do with it, I think is really important in order to be able to use Java or C# well.
You know, I have to maybe say something slightly different. We have had actually very good experience with people coming out of college compared to what you want to call veteran programs. It has to do, I think, with the new perspective that the college students have on actually what computer science is and how they're using it, as opposed to the older perspective on actually the old technology. And with the proper kind of nurturing, we've had great success with people coming out of school. And within months, they're much more productive than the best people that they were being compared with. And it came back to the original discussion we were having, really the fundamental understanding of what things are, very much supporting what we said so far. If you have a good fundamental understanding of what a system is, or what systems are, what are the components, what are the layers, what are the architectures that are out there, and actually the schools that we have dealt with have done a pretty decent job of introducing them, not maybe completing it, and then having somebody that actually shows them the steps. Okay, now you know the abstract ideas. Here is an implementation. Take a look. Let's spend a few hours kind of dissecting this thing, and you ask a lot of questions. So from that perspective, we've been very successful. Now, I have to say there are a lot of exciting areas. Going back to another question that was brought up here, there are a lot of exciting areas, but there are not thousands and thousands of people working in those exciting areas. I mean, the people who are working on concurrency of monumental amounts of data, I'll guess 1,000 around the world. It just is maybe 200 in the States and, you know, the rest of the world. So I think the schools are also focusing on trying to put the basic programming staff for, I don't know, implementing enterprise accounting, whatever. All of those things have to be also filled. So the schools are very much focused on that, but you can find people, if you spend time, that come out of school and they do a pretty good job, I have to say. I've been very impressed.